Hello and welcome to 6.3 arc length. Okay, today we'll be talking about how to approximate the length of a curve on a closed interval. Okay, so here we have a diagram of a curve in blue, and you see the segments in red are just the approximations of the length of this curve. Okay, so with the definition we're going to give today, we're going to get the exact length of that curve on a closed interval. Okay, so let's take a look at the definition. Again, the definition is on a closed interval from A to B. Derivative has to be continuous. Okay, and this is the definition. So we have the square root of 1 plus the derivative with respect to x squared, all under a square root, and we integrate it from A to B. Okay, so here we have our first example. I put the graph on the right here, bottom right. This is the section of the graph that we're going to get the length of. And we have the function. Okay, it's the x to the 3/2 power with a coefficient in front, and it's a -1. Okay, so the interval is between 0 and 1. The first thing I would suggest as you do any of these arc length problems is to figure out the derivative. Okay, notice up here in our definition there's two versions of the derivative. We have the version with f prime of x notation, and we have the notation of dy dx over here on the right. Okay, just a different way of writing it, obviously. Just be aware of the two versions. Okay, so let's do dy dx, or f prime of x, for our function. So when we do f prime of x, I'm going to keep the coefficient. I'm going to use the power rule on the 3/2, so I'll bring that down. So 3/2 times x to the, drop the power by 1. So if I subtract 1 from 3/2, I'm subtracting 2/2. So that means I'm left with x to the 1/2. And then derivative of a constant here with the -1 is 0. Okay. So when I go to simplify this, I can cross cancel the 3's. I can reduce with the 2's, divide by 2, the 2 and the 4. So I divide by 2 here, I get 1. Divide by 2 here, I get 2. Okay, so my first derivative ends up becoming 2 square root 2 x to the 1/2. You can also write this as 2 square root 2 and then bring the x in, because the square root 2 is also to 1/2 power. Okay. But now next step is we need to take this derivative and square it, because in our definition we have the first derivative raised to the 2nd power. Okay, so we're going to square that. So 2 square root 2x squared. The 2 squared is 4. And then the square of the square root here, those will cancel, so we just have the 2x. So that gives us 4 times 2x, which is 8x. Okay, so that piece is 8x. Okay, next we're going to add 1 to it, put it under the square root. And our integral here is from 0 to 1. So we have 0 to 1, 1 plus 8x, and this is with respect to x. Okay, so now we could integrate this. We could do a little u substitution here. You could do u would be equal to 1 plus 8x. That means du would be equal to, derivative of this would be 8. So du would be 8 dx. Notice we don't have an 8 dx there, right? We just have a dx. So if we solve for dx, we get 1/8 du. Okay, so we have the square root of u, which is u to the 1/2, and the dx is 1/8 du. Okay, we could pull the 1/8 out. So we have 1/8 u to the 1/2 du. Now we could integrate it. So we have 1/8. Now the integral of this becomes, we add 1, so it becomes 3/2 u to the 3/2. Divided by 3/2 is the same as multiplying by 2/3. And then we're going to plug in the 1 and the 0. Now before we do that, I have to emphasize, we plug back in for the u, right? Substitute back in for the u. So the bounds there would actually be incorrect because we're dealing in terms of u. But let's plug in first the 1 plus 8x, and then we'll be good to go. Plus 8x, and now we could plug in our 1 and our 0. Okay, so just plug it in. So we have 2/3 1 plus 8 times 1 to the 3/2 minus 2/3 of 1 plus 8 times 0 to the 3/2. Okay, now we just evaluate. It's just arithmetic from here on out. Okay, so inside the parentheses we have 8 times 1 is 8, plus 1 is 9. So we have 9 to the 3/2 minus 2/3 of 8 times 0 is 0, plus 1 is 1. Okay, now we simplify 9 to the 3/2. We can take this, the denominator means the root, so take the square root of 9, which is 3. 3 cubed is 27. So we have 1/8 of 2/3 of 27 minus 2/3. Square root of 1 is 1. 1 cubed is 1. And then we could simplify between the 3 and the 27. Divided by 3 is 1. 27 divided by 3 is 9. So we have 1/8. 2 times the 9 here is 18. And then 2/3 times 1 is 2/3. Okay. And now we could simplify inside the parentheses. We have 18 over 1. We're going to get that to be a common denominator. So we have 18 over 1 multiply by 3, top and bottom. That would give us 54 over 3 minus 2 over 3. So that gives us 52 over 3. And then we could reduce when we multiply that. We could reduce the 52 and the 8 by 4. So if I cancel, divide by 4, 8 divided by 4 is 2. 52 divided by 4 is 13. So I am left with 1 times 13, which is 13. Denominator is 2 times 3, which is 6. So final answer would be 13 over 6. Okay, that's how we do a typical problem like this. Okay, let's take a look at our next problem. Find the length of the graph of, so we have our function, and we're between x is 1 and 4. So just like with the other one, we're going to take the derivative first. Start with the inside out. Take the derivative. So when we take the derivative here, we have, I'm going to write this as 1/12 times, bring down the power of 3, drop the power on the 3, so it becomes 2. And then the 1 over x, that's x to the negative 1. So when we take the derivative, bring down that power, so negative 1, x, and then drop the power on the negative 1 by 1, so negative 2. So that gives us 3/12, which will be 1/4. So we have 1/4 x squared minus, and then I could write this as 1 over x squared. Okay. Okay, so that's our first derivative. Now let's square that. So we have 1/4 x squared minus 1 over x squared. And then we're going to square it. So when you square this, just picture two of these next to each other, foil this out, right? I'm going to foil it out. So you have 1/4 x squared times 1/4 x squared. That would be 1/16 x to the 4th. And then we multiply 1/4 x squared times negative 1 over x squared. So that'll give us negative 1/4. And then we have two of those, so that's negative 1/4, negative 1/4, that's negative 1/2. And then negative 1 over x squared, square that, that'll be a positive 1 over x to the 4th. Okay. So now if we, that's the derivative squared. Next part is we add 1 to that. When we add 1 to it, we could combine the 1 with the minus 1/2. So that gives us a plus 1/2. Okay, so that means we have 1 over 16x to the 4th plus 1/2 plus 1 over x to the 4th. Okay, what's significant about this is we could actually rewrite this as something squared. Right? This just turns into, if you look at the previous line, it turns into this binomial squared, with the only exception is instead of the minus, we have a plus. Okay, so we could rewrite this as 1/4 x squared plus 1 over x squared quantity squared. Okay, which works out nicely for us because when we put this into our formula, we're going to integrate, go 1 to 4. This will be put under the square root. Well, the square root and the square will cancel each other, right? and then we can rewrite this as integral 1 to 4 of 1/4 x squared plus 1 over x squared with respect to x. Okay, well, we can integrate this. Right, so keep in mind we have 1/4 x squared, and then we can say this is plus x to the negative 2. Integrate it. So that means if we add a power to the x squared, that becomes x cubed, and then x cubed divided by 3, or multiplied by 1/3. We already had the 1/4. And then for the x to the negative 2, we would add 1 to that. We have x to the negative 1 over negative 1. Okay, so this gives us 1/12 x cubed minus 1 over x. And then we could begin to evaluate that. Okay, so let's finish this off. Let's plug in 4. So we have 1/12 of 4 cubed minus 1 over 4 minus 1/12 of 1 cubed minus 1 over 1. Four cubed is 64. We have 64 over 12 minus 1 over 4 minus 1 cubed is 1 times a 12th is 1/12. Okay, so now we have 64/12 minus, let's put this in 12ths, see if it works out nicely. 64/12 minus 3/12. If we distribute the minus here, we have minus 1/12, and then minus of a minus is plus, and this will be 12/12. Okay, so that gives us 64 minus 3 is 61. 61 minus 1 is 60. 60 plus 12 is 72. So 72/12, which reduces, we could divide both by 12, right? This divides evenly, so that gives us 6. Okay, so 6 will be the final answer. Okay, let's take a look at the next one. Find the length of the curve. Okay, so here we have the curve, and we're going to go between 0 and 2. Okay, so again, first thing we would do is find the derivative. So our derivative, I'll use dy dx for this one. Derivative here would be, we could have 1/2. Now, derivative of e to the x is e to the x. And then derivative of this one, e to the negative x, would be e to the negative x. And then we take the derivative of negative x, which is negative 1. So we'll have a minus e to the negative x. Okay, so that's the derivative. And then we're going to take the derivative and square it. Right, so if we take the derivative and square it, when we square it, so we have 1/2 e to the x minus e to the negative x, and we're squaring this. Go underneath. So when we square the 1/2, we have 1/4. Now when we square the binomial e to the x times e to the x, that gives us, we can just add them, right? And we get add the powers, we get x plus x e to the 2x. Okay, then when we do e to the x times e to the negative x, or we're actually going to do e to the x times negative e to the negative x, that gives us negative e to the x plus negative x, which would be 0. So this gives us negative 1. And we have two of those, right? Because we FOIL this, we have a negative 1, and we have another negative 1, so that's a negative 2. And then a negative e to the negative x times a negative e to the negative x, that's a positive e to the, add negative x and negative x, that's negative 2x. Okay, so that's our derivative square. Next, we're going to add 1 to this. So now when we add 1 to it, we could actually simplify it a little bit. Right, because we have this 1/4 on the outside. So if we have that, picture that, that's 1/4, let me distribute the 1/4. 1/4 e to the 2x minus 2/4 plus 1/4 e to the negative 2x. Now I combine my 1 and my negative 2/4, which is really negative 1/2. 1 minus a half, that's plus 1/2. 1/4 e to the 2x plus 1/2 plus 1/4 e to the negative 2x. Now if we rewrote the 1/2 as 2/4, that would actually work out a little better because that works in our favor. That means then we could rewrite this as 1/4 e to the 2x plus 2 plus e to the negative 2x. So now if you notice this quantity, right, kind of looks like this quantity, right? And that quantity was something that we squared. And we squared it originally from this step. Okay, so that allows us to actually rewrite this in a friendlier form. And we could say that this is a perfect square of 1/2 e to the x plus e to the negative x, and it's that quantity squared. So now we could plug into our formula. The curve for this one was between 0 and 2. We have the square root. We already added the 1, so we have 1/2 e to the x plus e to the negative x. That quantity squared. The x. And now these two will cancel. The square and the square root will cancel. So we're left with integral 0 to 2 of 1/2 e to the x plus e to the negative x dx. Okay, I can pull the 1/2 out. Okay, when we integrate e to the x, we have e to the x. When we integrate e to the negative x, we'll have a negative e to the negative x. So we might as well go right to the integral, already integrated form. And we're going to integrate, plug in 2 and 0. Okay, so now, next, we plug in the 2. So we have e squared minus e to the negative 2 minus e to the 0 minus e to the 0 . Well, the second half here, if you look at it carefully, e to the 0 is 1 minus, and then e to the negative 0, well, negative 0 is 0, so that's, again, another e to the 0. So 1 minus 1 is 0. So that part is a big 0. Okay, and then we're just left with 1/2 e squared minus e to the negative 2. And then that would be as far as we could go. If we were to go any further, we would have e squared minus 1 over e squared, and we have the 1/2 here. So you could have that. If you want to distribute the 1/2, you could do that as well. That would be e squared over 2 minus 1 over 2e squared. Okay, well, either of these versions is fine. Okay. Well, that would be it for that problem. Let's take a look at what happens when you have a curve and now you're basing it off of the y-axis instead of the x-axis. Okay, so now obviously things are gonna change a little bit. Instead of from a to b, you're gonna be integrating from c to d. Make sure your derivative is continuous on c to d, and make sure your function is expressed in terms of y. X equals in terms of y. Okay, so here we have a curve, and we're going to go from 0 to 2 based on x. I provided the graph here. Okay, now when we go to y, we will go from, instead of x equals 0 to 2, we'll go based off of the y-axis. So here this will be based off of 0 to 1. Okay. So our integral will be from 0 to 1. Another thing we have to do is change this curve to say x equals in terms of y. Okay, so let's do that right now in the beginning. Right now we have y equals, it's x over 2 to the 2/3. Okay, so to undo the 2/3 power, we can take both sides and raise it to the 3/2 power. Right? We flip the power on the exponent just to neutralize these. So we have y to the 3 halves equals x over 2. Okay, so next, to get the x alone, we multiply by 2, both sides. So we end up with x equals 2 times y to the 3 halves. Okay, so that's our function when we solve for x. Okay, next you want to take the derivative. Again, the process is similar. Now you just take the derivative with respect to y. Okay, so I'm going to do dx dy. So that means I would take the power, bring it down, times the coefficient, y, drop the power by 1, so I subtract 2 over 2, so that's 1 half. Okay, simplify that, the 2's would cancel here, so I'm left with dx dy equals 3 y to the 1 half. Okay, next I will square that, because we have dx dy squared, so this is 3 y to the 1 half squared. So 3 squared is 9, and square of the 1 half, that's the squaring of a square root, so that's just y. Okay, so dx dy squared is just equal to 9y. Okay, then we're going to add 1 to it. And so now we're ready to do our integral. Okay, so remember the integral was from 0 to 1. Okay, so we have integral 0 to 1 of the square root of 1 plus 9y with respect to y. Okay, so now we could integrate it. We're going to use substitution here. 1 plus 9y du would equal 9 dy. Okay, we don't have the 9 there, we just have a dy. So dy would equal, divide by 9 both sides, so we have 1/9 du. Okay, so that means here, we have a square root is to the 1/2 power, right? That's the 1/2 power, so we have u to the 1/2, and then we have 1/9 du. Pull the 1/9 out, so we have 1/9 integral u to the 1/2 du. Okay, we can integrate this. We have 1/9. It's going to be 3 halves. We have to divide by 3 halves or multiply by 2/3. Okay. That means here I have 2 over 27. I substitute back for my u. So plug back in the 1 plus 9y. 1 plus 9y to the 3 halves. And now I have my evaluation piece to do. Right? So plug in the 1. So we have 1 plus 9 times 1 to the 3 halves minus 2/27, 1 plus 9y. So the y we plug into 0. Okay, so what does that give us? We have 2/27. 9 times 1 is 9, plus 1 is 10, minus 2/27. 9 times 0 is 0, plus the 1 is 1. The 3 halves. Okay, so next we have here we have 10 to the 3 halves. Now we can't take the square root of 10, right? But what this means is we could branch this out and say this is 10 to the 2 halves times 10 to the 1 half, right? And then here we have 2/27. Square root of 1 is 1, 1 cubed is 1, so we have 2/27 times 1. Okay, so now what does that mean? That means I could pull the 2/27 out, right? That's a common factor. Now 10 to the 2 halves is just 10. 10 to the 1 half is just the square root of 10. And then here on the right I have a 1, because I factored out the 2/27. And so this will be the final answer. Okay, that will be the final answer. And that would be it. Okay, very similar process as to the other ones. We just adjusted it in terms of y. Y in terms of x, I should say. Okay, any questions, just let me know. Email me. Any questions, bring it up in class. Okay? Have a good night. Have a good day. We'll see you soon.